as you dig into this, it can be quite revealing. And so that's why you just want to be careful. Even just reading the abstract of the study, let alone the title of an article from the New York Times about the title, about the abstract of a study.
This is Generation Health. Every week we bring you the latest in news, cutting-edge research, and time-tested best practices helping you live a longer, healthier life. Across from me, PharmD, certified strength and conditioning specialist, Dante DiMatteo. How are you, my friend?
Doing well. Doing well. How are you?
I have the 100-day cough, apparently.
Yeah.
That's what I found out yesterday when I walked into the pharmacy.
There's a lot of that right now.
It's, I'm going to try really hard not to cough into the microphone, but please forgive me. And third mic, Josiah Schweinberg.
Here I am.
How are you?
I have the 99-day cough.
Oh, you're just one better than me.
I guess.
I definitely still have a bit of mine too.
Yeah. It's bizarre. This season has been, you deal with it. I don't. I just have my friends and anecdotal evidence, but has it been particularly rough?
It certainly feels like it.
Yeah.
Yeah. And I never know quite what to make of that. I'm sure last year we were having similar conversations.
I remember seeing everybody talking about the triple-demic last year and freaking out.
Exactly. So yeah, you're exactly right. There we had an episode on the triple-demic, and it's just called something. There's no name for it this year. It's just that everybody's sick and
the 100-day cough.
Mm-hmm. Yeah, because I'm not sick. I feel fine. I just periodically cough.
Yeah, so many people I know got something.
We were at dinner.
Usually a virus, post-viral cough. Not much you can do. Usually don't need to worry about it.
My daughter is the same way. She's been fine. Mm-hmm. She got sick. She's been fine for 3 weeks now, and we're about to send a note with her into the school because I think the teacher's freaking out that, oh my gosh, is your daughter sick? No, she's fine. She just coughs.
There is nothing more embarrassing like being out somewhere and your child is just coughing incessantly. You're like, yes, stop that.
Please stop coughing.
Yep. Tyler and I were eating last night, and
did you catch it?
And he was coughing, and this lady turned around and she was like,
shot him in the eye.
I got side eye,
dude,
hard.
I felt so bad. I'm like, how are people? I mean, it's January, and there's been illnesses all around, and he's the first person that had a cough, and it's not like he was like,
I cover up. I'm protected. But
it was very loud, but it was controlled.
Thank you. Here we go.
What are we talking about today, Dante?
Yeah, we're going to debunk some studies or a study.
A study.
We should debunk.
I don't know if we're debunking anything, but we're going to poke some holes.
We should debunk cough suppressant.
Moving on. What is happening behind the counter? Sickle cell disease is an inherited genetic disorder that causes those with that genetic mutation to produce red blood cells that are sickle-shaped. They should be round. That sickle shape means that they can't effectively carry oxygen through the blood the way that they should, and will lead to lifelong problems like organ failure, anemia, strokes, and of course, severe pain. Ultimately, most people with sickle cell disease will die by their early 50s. This disease has been incurable until now. The FDA has approved 2 new gene therapies using CRISPR, a cutting-edge technology that allows the direct manipulation of the genetic code. In this case, it allows an individual's mutated genes to be edited so that they begin producing healthy red blood cells. The process is very long, very complicated, expensive, and not without significant risk. A patient first has to have their stem cells harvested from their bone marrow. Those cells are then sent to a facility where they're edited using CRISPR technology before being put back into the patient's body in a months-long hospital stay that also involves high doses of chemotherapy, in some cases high enough to cause infertility. Nevertheless, the treatment has been tested and it works. Patients treated with it have already seen remarkable results. In separate trials, 89 and 90% of patients went a year or more without any sickle cell attacks. The treatment is incredibly expensive. Think multiple millions of dollars, and getting it approved by insurance will, of course, not be easy, but this is a revolutionary hope for people who previously had none. When we're talking about a terminal disease, you will go through a lot of things to not have to deal with that. The FDA is now publicly publishing a database of companies and universities they have sent pre-notices of non-compliance to regarding clinical trials. Federal law requires certain data to be regularly sent to the FDA, and failure to provide that data is initially corrected via a simple notice. Publicly publishing this data is both a way to increase public pressure with those standards and an effort at greater transparency on the part of the FDA. Big names you might know that are on the list as of right now: Novartis, Bausch & Lomb, and Georgetown University Medical Center for various different studies. Upon receiving the notice, companies have an opportunity to provide the relevant information. Failure to do so means that the FDA can issue a full non-compliance notice and seek financial penalties. If you are curious about those companies, they are also available in a database. There's only a few. Thankfully, 5 so far. The real question, though, I think, is, Dante, are you on any public databases that we might need to check out?
I sure hope not.
I always worry that somehow I'm going to end up on a no-fly list or something and find out last minute that I can't come for some reason.
Is that like an intrusive thought, potentially?
It really is. It really is. It started, I'll tell you when it started, this past summer when we were summering in Spain.
I'm on the list.
Are you?
Or like just,
yeah,
I'm on a list.
I'm on the list. We were going to, my wife and I were going for our anniversary overseas. And
Caroline's going to find out I'm on the list.
We rolled up to the airport and tried to go through security, and they were like, let me see that ID again. Let me see your boarding pass. Can you step over here? And I was like,
it's happening.
I guess. Yeah, I've been panicky ever since then, but no reasons, I don't think. I think we're okay. So there's a big study that came out recently, and the New York Post put out an article about it, and I want to just read this directly. Is exercise aging you faster? The ambitious study on the oft-discussed subject has yet to be peer-reviewed, but recently won National Sports Prize in Finland, where the research was conducted over a 45-year period. Participants self-reported the time and intensity of their daily physical activity and were categorized into 4 groups: sedentary, moderately active, active, and highly active. Overall, they found that those who exercised the least were about 20% more likely to die over the 45 years than those who were regularly active. I should note here, I don't think it said in the article that I've read here, it was a study of twins.
Yes.
Which is a really relevant point. So it's a very interesting control group that they've got there, which is great.
More than 11,000 Finnish same-sex twins were analyzed between 1975 and 2020.
Exactly. So when they filtered for lifestyle factors, including education, BMI, smoking, and alcohol consumption, that number dropped significantly. That number being the number who were less likely to die. Then those in the sedentary group were only 7% more likely to die compared to those in the active group with, quote, no additional benefits provided, unquote, by higher levels of exercise. Those who were the most physically active were about 1.8 years older, in quotations, than those who did a more moderate or modest amount of physical activity. The researchers concluded that those who exercise may not live longer because of their workouts, but because they are generally living healthier lives. So the first part, if you exercise, you're about 20% less likely to die. Sure, that makes sense. But then they undercut it all and say that we're physically older and not really less likely to die. On the NIH website, right at the very top in a big green box, it says, this is a preprint. It has not yet been peer-reviewed by a journal. The National Library of Medicine is running a pilot to include preprints that result from research funded by NIH in PMC and PubMed. Okay, my BS radar is going wild. Is this just a clickbait title, or is there something of value and substance here? I would hate to think that 45 years of research was wasted, but I also don't like the idea that exercise doesn't actually redound to a net benefit.
It is 100% a clickbaity title.
Okay.
There's no doubt about it, but there is still, it never hurts to for as something as obvious as exercise is good for you, it's still sometimes good to see what potentially the other side
not
of
be
that argument
afraid
is.
of a counter argument.
Right. Because the majority of, whether it's a prospective trial or it's, something more backwards looking, some sort of cohort or snapshot, whatever the case, for the most part, resistance training, cardio, whatever you want to call it, those all generally point in the direction that the more that you're able to do, the better. And especially if you're starting from zero, that initial bump upwards and increase of, in this study, they call it leisure time, physical activity, or exercise, whatever you want to call it. Any sort of bump from baseline portends the most benefit. And for the most part, depending on what graph you look, depending on which one you look at, the amount that you're doing is going to be, proportional to the benefits that you're receiving.
But what you're saying is that this is one study. There's literally a mountain of other studies and research, all confirming that exercise is absolutely going to help you live longer, right?
Mm-hmm. Definitely.
Okay, so let's get specific. What is it that's going on? What are they actually researching? You said that the article is clickbaity. What is the actual study saying? What can we take out of this? What are they proposing or putting forward as what they've discovered?
So as we break this down a little bit, the one point that seems to get glossed over, in my opinion, is, so if you just look at the title of the actual research paper, the associations of long-term physical activity in adulthood with later biological aging and all-cause mortality, a prospective twin study. So biological aging, what is that even talking about?
Yeah, what is that?
In our minds, logically, it makes sense. You have chronological age, that's how many days, years, months, minutes have I been alive?
Right.
Biological age, the thought that there's something more than just your chronological age. You might be 50 years old, but at the cellular level or based on other health metrics sort of aggregated, your biological age might say otherwise.
Okay.
Maybe you have a really healthy genetic phenotype or disposition.
Yeah.
And maybe they say based on this algorithm that your biological age is 47.
Right.
Or, for some other people, in one of the articles I read, they use the example of you go to your 25th high school annual, your 25th high school reunion,
right.
And you look at somebody who's, should be 50 or whatever, and they look like they're 65 or they act like they're 65, 70. And so there's these natural variants and
so like when you
in potential discordance between how old you are chronologically versus what is maybe happening under the hood. So is the thought.
Yeah. So you're talking about when you're a smoker and you go to the doctor and the doctor says, oh, you're 35, but you've got the lungs of a 70-year-old.
Yes.
Something along those lines.
Definitely.
Okay.
Definitely.
Do the algorithms that we're talking about, the averages of whatever age appropriate biological measurements, those change over time, don't they? Because they're aggregated based on what normal looks like for people at that age at that point in time. Is that fair to say?
I would say so.
So theoretically, if society is getting healthier, then a 40-year-old will actually look younger, in air quotes, biologically now than perhaps, say, in 1970.
Potentially.
Okay. I just total side issue. I thought that was interesting.
Yeah. The so what they call them epigenetic clocks.
Okay.
Or the word or the essentially the category of these biological age quantifiers, if you will. So they used a couple different ones in this study, and I'll be completely honest. This is above my knowledge base, above my pay grade, so to speak. How these algorithms actually work.
Sure.
It's at the point where there are companies selling kits, urine kits, saliva kits, blood tests, looking at these different things that, again, they're starting to, for $200-$300, you can pull this information together and it'll spit out a biological age.
Turn back your epigenetic clock.
I don't care what anybody says. I mean, as of, Tuesday, January 9th, we're recording this. There's no way those are ready for the shelves. I'm sorry. There's just no way that they can reliably, nudge you in a direction that you wouldn't be nudged otherwise by looking at cholesterol, blood pressure, what physical activity you're doing,
right?
What does your diet look like? What is your family history?
Right.
All those sorts of things that do you really need it to spit out a biological age
right.
for it to nudge you in a certain direction? I kind of, at least I'm always open to changing my mind, but at least at this stage, I just don't know for $200-$300 or more that, using something like this out of context of a practitioner, so to speak, that it can really do much for you. And not to get lost on that. I think I always say it, but as we shoot these episodes, there are things that pop up that would make for interesting topics and interesting discussions in and of themselves. And I know we went off on a little bit of a tangent.
It's all right.
But I'm certainly not at the point where we can break down the, DNA Grim age clock or the Duned in pace clock, which looks more at the rate or the pace of one's aging. So there's a lot out there, and that's I guess the point is I didn't want to lose sight of these things in the context of this paper.
Right.
This paper wasn't just looking at exercise, who lived the longest. They were using biological age as the proxy of, was it exercise that reduced biological age, which therefore reduced mortality risk? There's just a lot here. There's life expectancy, which is, looking at chronological age.
Right.
They're using biological age, and they're using these algorithms to figure out what's happening. And they were trying to parse out the idea that, okay, we have all these prospective studies that say exercise and leisure time physical activity reduces your all-cause mortality.
Right.
But is it because it's causing our biological age to turn back? That in my mind is more what, gets at what this paper is asking, and just at the fundamental level, because these algorithms can spit out some really accurate information and they're incredibly high level. I'm not saying that they're not.
Right.
But just the fact that we're still maybe not quite there with clinically and, contextualizing a lot of that information. Can we really use this and also look at this study design, let's say, and say, oh yeah, now we know for sure exercise isn't what we thought, and it's not causing a reduction in mortality risk. This was not they didn't randomize anybody at the start. They just, they pulled twins and I mean, granted, it's a great data set.
Right.
It's
11,000 twins. Where do you find 11,000 twins?
In Finland,
it's
apparently.
Completely unique in that regard. But again, it's not like it was a randomization process to, this set is not going to exercise. And, it's
right.
It's
especially for 45 years.
Yeah. It still paints a picture that I'm not so sure is crystal clear.
Okay. All right. So let's talk about the design of the study. And for those that are wondering, why are we spending all this time talking about a study that we're saying isn't really saying what people are saying it's saying?
Yeah.
The reason is they make headlines. This is the stuff that constantly gets thrown out there and people get very confused. They read one article with a clickbaity, title and they think, oh, that's it. I guess I'm never exercising again.
Or they don't even read through the full article.
Right.
Which is why I think, Dante, it's good to highlight, like even in the title, it's biological, it's not even the chronological age.
Yeah.
Mm-hmm. Very interesting.
So how did they do this? They've got twins in Finland.
Yeah. So they the participants provided information about their physical activity levels at 3 different points in time. So there was 1975, 1981, 1990. And as we said, the over 22,000, 23,000-ish twins.
So it's 11,000 pairs of twins?
Yeah.
Wow. Oh, that's even wilder. Okay.
Yeah. And then there was an additional subgroup of 11 or 1,200 that they looked more closely at these DNA-based aging measures. Or that's what goes into those epigenetic clocks.
Right.
So there was there was a lot happening here. Now what they did was they looked at the differences in short-term all-cause mortality. They tried to look at long-term all-cause mortality, and again, as well as the biological aging sort of points that were investigated. They also lumped, I think you mentioned, they lumped the physical activity amounts, or the cut points into 4 classes: sedentary, moderately active, active, and highly active.
Right.
So the sedentary, for example, the first class, they fell well below the 150 minutes per week recommendation. And then those that were active were right around that mark. And then as you got higher, it was at above or well above the classic physical activity guideline cutoff point that we talk about, the 150 to 300 minutes, moderate to moderate intensity activity.
And how did they get this data?
So that's a hugely important question. So what they did was, at those different points in time that I mentioned, they sent out surveys to the participants.
So it's self-reported.
So this was self-reported information. And to my understanding, they were also self-reporting their height and weight. And so in general, there is the tendency, there's been a lot of these studies looking at leisure time physical activity that don't use accelerometers that we've talked about before.
Yep.
So it's not that, we just throw all this data out the window, but as you begin to, poke some holes, the fact that this is essentially all self-reported physical activity data and, BMI data, as in height and weight. And again, the point that I was getting to is that we tend to underestimate our weight when reporting typically. And we generally overestimate the amount of physical activity that we're doing.
Yeah. If you ask me, I'm 6 foot tall, but I'm not 6 feet tall. I have to wear shoes to get 6 feet.
Right. And that's,
that affects BMI.
It does. That's how it's calculated. And so I guess the point is, you're already kind of starting with, faulty,
questionable
measure. Yes. You're starting with a questionable baseline level of, important information, given that this is looking at leisure time physical activity exclusively, and, different health metrics like weight, body weight, and all that kind of stuff.
And unless you were really into physical fitness, especially in 1980, 1990, we didn't have smartwatches. We didn't have phone apps to help us keep track of this stuff. It wasn't, that easy to pay attention to as it is now. So someone's idea of how often they exercise may be questionable to begin with.
Right. And so looking at the survey that they used in 1990, this is just for example, how it was set up. Following questions are about your physical activity during leisure time or during your daily journey to work during the last 12 months. How many hours in a week do you engage in physical activity corresponding to each intensity level? And so
this is in what year? 1990, you said?
1990.
Oh gosh.
And so then what they did was we've talked about METs or metabolic equivalents. And so that's how they, quantified the intensity of the activity. So walking has a MET score of 4, alternately jogging and walking had a score of 6, jogging alone 10, running 13. So it just goes up in intensity. And so first of all, that's only looking at, cardiovascular activity.
Right.
And then also it looked at duration. How long?
Yeah.
Not at all. Less than 30 minutes per week, 30 minutes to less than an hour per week. And then it
goes on from there.
Yeah.
Right.
And so that's it.
That's it.
That's from my understanding, that was the extent of the questionnaire. So there's I just find it hard to believe that you were getting really solid activity measurements.
Okay.
And the other aspect is, I know this was in, years past, but it's not like in 1975 and 1990, people weren't lifting weights.
Right.
And so when you look at this questionnaire, you're like, well, I do walk to work, and I mix in some jogging some days, and maybe that's an hour per week, but I also I have a weight set and a bench press in my garage.
Right.
What about that? So I guess that, that
doesn't count
here. And again, I'm happy to be proven wrong. But it looked very narrowly at physical activity. There's certainly much more than just.
Yeah, I was gonna say, it didn't mention swimming or biking or rowing or all kinds of different things that people do because they enjoy it. Pickleball. Yeah. I guess pickleball probably wasn't around back then.
Tennis.
Yeah. And so maybe that was a snapshot at the questionnaires that were used, but as far as what's available in the supplemental material, that's the extent of what they were asking. Getting a very, very, very basic understanding of what kind of activity was being done.
And this is all information that you're getting by digging into the actual study, which most people are not going to do when they read a headline or even read the entire article. They're not going to see this kind of data. Okay.
Yeah.
Which is why we have this show.
That's right.
Yeah. And and we're not a research review panel.
No.
And I think that as we continue to kind of get better at this, we can dig further into some of these methods and different designs that are used. But again, like I think you said it perfectly. As you dig into this, it can be quite revealing. And so that's why you just want to be careful at, even just reading the abstract of the study or the title of the study, let alone the title of a article from the New York Times about the title, about the abstract of a study. It's just gets things can get lost in the sauce here. But,
yes.
The other thing that I wanted to mention, just kind of getting back on track here.
Yeah.
Like we mentioned at the outset, the benefits of leisure time physical activity are generally the greatest as you go from 0 to
10.
Right. As you kind of go
0 to 1.
Right. As you go from baseline, you can really, no matter what it is, 1 minute, 2 minute, 3 minute bouts, 3 times a day, 30 minutes of walking. I mean, if you're going from nothing to something, I don't care what anybody says, there's a ton of benefit to be realized there. But then as you become more adapted, you have to, do the commensurate amount of activity to match your new level of fitness. So those increases, the beginner gains, so to speak, start to level off slowly over time.
Yeah.
And then there's the argument of, are there diminishing returns past a certain point of exercise? And then not only diminishing returns, does it then taper off the other way? And does it become harmful,
detrimental
at extreme levels of exercise? And again, that's another, similar to the epigenetic clock discussion. I think that's the discussion kind of for another time as well.
Yeah.
But what a lot of people I can tell are doing with this paper is, balance is everything.
Yeah.
You start exercising too much, and that's what I always thought.
Yeah. Yeah.
Balance.
Yeah.
These people, see what happens when you exercise way too much. It's harmful.
Yeah.
And it's not worth it. Well, I think, the vast majority of people are way off.
Yeah.
From hitting that point of, I'm doing too much.
Yeah.
So I just can't even go there with this.
Yeah. I'm exercising 5 days a week, and I don't feel like I'm anywhere near too much.
And again, this is just this is just theoretically conditioning.
Yeah.
We're not even, this isn't even addressing the 2 days, 3 days a week of, full body muscle strengthening activity.
Right.
So
yeah, that's what I was going to mention is maybe it's exercising is, you hit this too much level, this mark well, maybe you're doing the same exercise or the same movement over and over and over and over again. Like, oh, I can't run anymore. My knees, I exercised too much. Now my knees are giving out. Well, you just ran the whole time. You didn't do any other, strength and mobility exercises. You didn't do full body workouts. You didn't do
right.
There, in addition to that, I mean, there's the extreme exercise hypothesis, which they're theoretically trying to come up with what is that point, on the curve that once you hit here, you maximize your benefit, and any more of that, it goes back up to something that was decreasing your health risk. Right. All of a sudden, once you hit that point, not just your knees, ankles, whatever, your joints, like there's something structurally changing with my heart, and there's, these things happening under the hood. Something's happening to my DNA methylation pathways because I do too much leisure time physical activity that there's something to it. Yeah. I mean, you can't just exercise into oblivion. Right. And I think that if you're somebody that's doing 1,000 MET minutes per week of exercise, that there's probably not much left to be realized at that point. But I mean, you're talking about such a small percentage of the actual population. So anybody who looks at this and they're like, yeah, see balance, like, yeah. Balance. So, it's like, that's not what this is saying either. To say it directly, if you're watching this podcast, it's not you. Right. That's not you. You're not exercising that much. Okay. Right. And even in this paper, the class 4 or the most highly active people, where they say, oh, look, see this group and the first group. Yeah. They're saying, oh, these two are similar. Yeah. This first group, they're not doing enough physical activity, and there's an increase in mortality risk. And at the far end, see, there's some potential harms that are being done in terms of what's happening to your biological age. It's like, sure. I mean, on the surface, that's what that's saying. I'm not arguing what this paper is saying on its surface. You look at the other 50 studies looking at, long-term physical activity patterns and intensity and how it affects all-cause mortality, cardiovascular risk, all of sorts of things. It's pointing in generally a different direction. And also, again, that idea of the extreme exercise hypothesis and sort of diminishing return, that's a factor. Yeah. It's a factor, but it's just generally something that most people in their lifetime who work 9 to 5 and have kids and have a life. Yeah. I'm just not so sure that you have to worry about that other end of the spectrum. Right. For the most part. Yeah. If you're not a professional athlete. I mean, yeah, we're talking about professional ultra marathoners, like running hundreds of miles a week, swimming, hours upon hours upon hours a week, and cycling. And I mean, just extreme levels of activity, which you could even still make the argument that not 100% of those people have damaged hearts and, ventricular hypertrophy that's damaging and have a higher risk of sudden cardiac death and all these things. I mean, not every single one of those, that doesn't happen to every single one of those people. It's just that, yes, there may be, when you hit that like truly, peak point, top of the pyramid, that maybe you have sort of a jump in risk, but that is we're just 99% of people don't have to worry about that.
Say it one more time for the people in the back.
I know.
That's not you.
Yeah, exactly.
Not us. None of us.
It's not us.
It's
okay. So one of the major points that they made in the article, and it seemed like I read some quotes from the author of the study, the main lead author. They kept saying, when you separate out BMI, smoking, drinking, all those things, when you take those out, those have a higher correlation than the physical activity to reducing all-cause mortality. So they're just constantly pointing out that correlation is not causation, that when you exercise, that doesn't necessarily mean you're going to be healthier. Okay, but aren't they also kind of counter-correlating and saying, therefore, exercise is not going to make you healthier?
Exactly. Yeah.
Okay.
And I mean, the other part there is, as big of proponents as we are, or shills for exercise.
Yep. Big exercise.
Yeah.
Yeah.
We're not saying that that's the only thing you need to worry about. I mean, again, it's just, you get so lost in the minutia of an individual paper, individual abstract article that you just lose sight that, I mean, exercise is, people like Peter Attia, it's the, most potent longevity drug. And I like that.
It's a big lever.
It's a big lever to pull that most people can pull and have access to pull. You know, there are different, socioeconomic factors and such there as well. But in general, this is a place to start for the vast majority of people. But we're not saying that it's the only thing that matters here. And it's just that this idea that, if you control for BMI and you control for smoking, well, doesn't do anything. It's one thing to say that based upon their data set, but then they also put out this message that in the paper, I don't know if they were citing 1, 2, 3 specific studies. They made it seem like, these other studies that are looking at all-cause mortality and, leisure time physical activity, they don't control for those things. We controlled for them in this study. I tried to look at some of those studies. I don't think that is completely accurate.
Yeah.
I don't, I don't want to act like I know everything here, but I'm not so sure that that's a correct assertion that they've made. There are all you have to do is look up a couple of studies in this ballpark, and they do control for those things. Yeah. You know what I mean? Or at least they show some sort of attempt to do so. And you can't just control for everything.
Right.
Like there's just you can't just control yourself into control these variables into nothingness.
Yeah. You end up with a data set of one. So if that's the case, it seemed like they did say, oh, look, lower BMI, not smoking, and exercising all together result in a lower all-cause mortality.
Right. Which is what we've said always.
It was another study that basically, when you take that other stuff out of it, is saying exactly the same thing as all the others. And of course, somebody who is physically active, somebody who is in those top 2 tiers of leisure time physical activity is almost certainly going to not smoke, is almost certainly going to have a lower BMI than people who live a fully sedentary life.
Right.
Right.
And those things, like you're saying, those things go hand in hand. We don't say that exercising causes somebody to have a lower BMI.
Right.
Those things kind of go hand in hand. Exercise, truthfully, in the long run is not the biggest lever to pull as far as somebody losing weight, let's say, and reducing their BMI. Yeah. But those things certainly in time, due to a multitude of factors, eventually go kind of hand in hand. As you exercise more and you do more resistance training and you become more adept, then there's enough research to say that yes, you can improve appetite control. Let's say. But yes, we're not saying that like exercise, that's the cause.
The only thing you need to
BMI. That's not, so it's all of those behaviors. It's like always, it's the chicken or the egg thing as well. And so I'm not in a position to totally disregard the epigenetic clocks and such either, and say that there's no place for talking about biological age. There is absolutely a place to talk about that. I just don't know if that lumping all these things together and saying, okay, you know what? We were under the assumption that, again, leisure time physical activity, the way in which it was reducing all-cause mortality was this reduction in biological age. There's just more to it than that. Yeah. Again, like you said, exercising, increasing leisure time physical activity it's like a symptom. Do you know what it is? Like a sign of somebody maybe increasing their other health promoting behaviors and doing additional things and starting to quit smoking, starting to drink less. Yeah. Starting to eat differently when they're at restaurants. It's this complicated cloud of things that you can't quite just control for, no matter how sophisticated your statistical model is.
Especially over 45 years.
Yeah, they said a little bit of that in the article. They said generally only smoking status is adjusted for in analysis, but this may not be sufficient because current smokers who are physically active tend to smoke less than those who are sedentary. So it's just getting at the same thing.
Yeah.
Okay.
Exactly.
One thing in the actual study conclusion, it said, quote, being active may reflect a healthy phenotype, that being your genetic profile, instead of causally reducing mortality. So, I mean, that sounds to me like they're saying, look, your genetics are your genetics. You're going to die when your genetics say you're going to die, and that's all there is to it. Don't even bother exercising.
It sort of puts that message forth.
Right. And that's nonsense.
It is. It's a little too, I don't know, sensationalist, or not. It's not the right message. I don't know. For the vast majority of people in this space that know what they're talking about, I don't really think they bat an eye at this.
Yeah.
I just think it's just another thing to consider. There's just no way we can say exercise makes you age quicker based on this research.
Yeah.
Does it, okay, if we're looking at biological age, does it drastically reduce it to a magnitude that we care about right now that we can tell? Probably not.
Right.
But is it all we care about as biological age?
Right.
Do you know what I mean? Because again, just back to, you start exercising, you increase your leisure time, physical activity, all these things start to happen. You start to care about your lipid panels. You start to care about your cardiovascular risk and your family, all those things, your family history, and maybe screenings and blood pressure screenings and all these things. Those things obviously play a role in biological age.
It's a positive health snowball.
Right.
Once you start it rolling, maybe with some leisure time physical activity, you start watching what you're eating. You stop smoking. You do some other things, and that snowball picks up speed and picks up weight, and it gets bigger and bigger, and it has a bigger impact on not just expected lifespan, but your biological age, whether or not that really is relevant in most people's lives.
That's the sentence right here in the article. The researchers concluded that those who exercise may not live longer because of their workouts, but because they generally live healthier lives.
Amazing.
Yeah. I mean, I don't know. Maybe
it's not just one lever.
One might, right. It's like one might say we just talked ourselves in circles about this thing, but I don't care.
Yeah,
that's fine.
It is. It's relevant. People need to know this. What's a takeaway? What is that people need to hear who have maybe just stumbled on this article or found this episode? What is it that we want them to hear coming out of this?
I still think there's no downside to thinking critically about something that seems so black and white. Exercise is good for you. It reduces your likelihood of dying, or, increases your life expectancy.
Right.
Something so commonly agreed upon at this point, like a paper like this, which ultimately kind of calls that into question in terms of biological age. I think it's okay that if you read that headline that makes you, think a little differently or think a little deeper about it.
Sure.
And I also think it's okay to look at this and say, okay, there is another side. Yeah. There is a point at which theoretically somebody might be exercising past a point where they're realizing any sort of benefit. Not saying they're going to die quicker potentially because of it.
Sure.
This study might suggest that.
Right.
But it's okay to be exposed to that idea that there is another side.
Yeah.
But again, for the vast majority of people, and for the vast majority of people that, feel some type of way seeing this headline, you don't have to really worry about that other side yet. It takes a whole heck of a lot of exercise to be on the other side of the U-shaped curve here that they're talking about at the point where exercise can be, harmful to your biological age. So in general, I wouldn't let this change anything. I would be open about biological clocks. Know that that's something you're going to keep hearing more and more about.
Right.
I would be skeptical about those things. I would be open to the, extreme exercise hypothesis, or kind of that there is a potential other side to this.
Sure.
And then, start now, start yesterday. What about the downsides of not starting?
Right.
What about the risk of not going from 0 to 1? This does not change that recommendation, which is so fundamental to what we talk about anytime exercise gets brought up.
Right. There's still a mountain of evidence suggesting this is what you should do. Don't let one study.
This article is confirmation bias for people who want to say, I knew balance.
Yeah.
I knew it. Too much exercise. I knew it.
Oh my God.
See.
You need to go balance on out of here, and we are going to balance out of this episode. We have a whole host of products, all sorts of supplements and other jazz that you can find on our website. That is askjoedimatteo.com, DIMATTEO.com. That site is also where you can sign up for our mailing, our email newsletter, or find past episodes of this show or the show that started this, the Ask the Pharmacist show, fully archived, available online. Go check that out. If you have any questions, we want to hear about those. Questions at askjoedimatteo.com. Show notes, the article and the study, those are all available down below. And if you learned something, if you enjoyed this episode, if you are feeling convicted, give us a thumbs up or a 5-star rating. Leave a comment. If you have some unique way that you like to get your leisure time activity in, let us know. We love reading those comments. We try to respond to every single one. We love hearing from you. And the biggest thing you can do to help us out, share the show. Share it with somebody you know who needs to be listening and learning things about their own health so they can be empowered to be part of this Generation Health. Big thanks to Josiah Schweinberg, our engineer. Michael Deppish is our editor.
He gets 2 thumbs up.
Joyce Gibb, our nurse practitioner, who handles private consultations. Diane Silverman handles product. Terry does scheduling. Cecilia does distribution. And that's Dante DiMatteo over there. He's the one with the opinions. And my name's Tyler Andrews. Thanks so much. We'll talk to you guys next time.